In this scene, we'll be creating a stylized planetary weather system. We'll start with a basic FollowSurface rig, which we'll then utilize to demonstrate different ways in which the FlowField set in surface modes can affect the particles. We'll then create a rig using simple polygons and cloners to control the particle flow. And finally, we'll test the rig on different geometries. So let's jump right in. Okay, so welcome to Cinema 4D and a fresh new scene in which to create our planetary weather system. Now, first things first, we're obviously going to need a planet surface, a piece of geometry that can represent our planet, and the obvious choice there, of course, is a sphere. And then, of course, we need the particles to help us visualize the weather systems on our planet. So we're going to create an emitter. And a really quick way to create an emitter that's going to utilize this piece of geometry is to actually utilize something called the quick tools. And then there's a command called emit from object. Now, you don't have to go up and into the quick tools to find this. You can actually search for it in the commander. So if you bring up the commander, Shift C by default, and we just type emit from, and then it'll bring up these options. And then with the sphere selected, we'll just hit emit from object. Now, I'm going to rename this one emitter surface because it's not just going to be emitting from this sphere. We're going to test out other geometries later on. Now, you can see it's created this emitter and it's set it up in object mode and it's referencing our sphere correctly. And then it's also emitting from the polygon area, and the particle direction, initial direction, is normal. So it's going to move away from the normals. And if we hit play, we'll see them moving away. Now I'm going to change the display to squares just to make them a little larger and easy to see in the viewport. And I'm also going to go back to that object tab and I'm going to change the particle direction to random. So there we go. And now obviously they're moving away from the surface. We need to constrain them to the surface. And a really effective way of doing that is using our FollowSurface modifier. So I'm going to bring up the commander again. And I'm going to type xp and then start typing follow. And you can see here it's filtered to FollowSurface. Drop that in there. And then we're going to drag the sphere in here for now. And I'm going to go back to 0 and I'm going to press play, and you'll see our particles are now flowing across the surface. Now they're flowing very rapidly at the moment because if I go to the emitter, the emission tab, we've got quite a high speed there, 150 units per second. And obviously this is only 100 units or 200 units diameter. So I'm going to drop that down to 20. I'm also going to drop the radius down. If we zoom in here, you'll see that they are offset from the surface. If I reduce this radius down to say 0.2, they're going to hug that surface much closer. So that's much better. And I'm also going to start by adding a trail object. So an XP trail. So again, bring up the commander, XP trail, and there we go. Now, the trail, I don't need to have it store any thickness and color data, so I'm going to go to that tab and I'm going to check that off. That just means it's not storing any extra data and it'll keep performance nice and high. And there we go. We can see we've now got our surface being covered by particles and these trails. Now, one thing I want to note is that later on, we might want to experiment with different geometries, different topologies, that will be all referencing back to these XP objects. So things like the emitter itself is going to look at this object reference. The FollowSurface is going to also look at this object reference. But if we want to swap this sphere out each time, we're going to have to change it in each of these objects, and that can get a bit cumbersome. So a nice way to do this is to create a constant reference object for the XP objects, but that we can also swap in geometry in and out of. And the best one you can do for that is the connect object. So I'll add a connect object. I'm just going to turn the welding off of the connect object, and I'm going to put the sphere inside that connect object. Now what we can do is we can call this our surface. And then if we go to our FollowSurface, we remove the sphere, and then we can just pick the surface. And then I grab the emitter, and I also pick the surface. Now, the benefit of this is if I swap this out, and if I just play to check that that's working fine, it is correctly working. If I now grab another piece of geometry, say a torus, and I put that into the surface, and I deactivate and remove the sphere, you'll see immediately, without having to change all those references, it's working on this surface. Okay, so let's turn that off. And because we're starting to gather up objects here, I think it's a good idea to always add an XP system object. So let's add an XP system, and it adds an emitter by default if you have that on the options active. I'm going to delete that, and I'm just going to drag our objects in here like so. There's only a few of them, and I'm even going to include our geometry. I'm going to put it in the other objects tab, and then I'm going to put our torus up here because we'll come back to that later on, and I'm going to put them inside an inactive folder. And we do that by going to the other objects null, and we're going to hit the create subfolder button, and let's rename that inactive surfaces. And let's put our torus in there, and we can hide that from the viewport and render by Shift and Alt at the same time and clicking the traffic lights. Now I'm also going to remove the icon from the system up here, so I'm just going to go to the system object. I'm going to turn the icon off. I'm also going to check on only modifiers in the same system and only deformers in the same system. It's just some good housekeeping. And then if we go back to our emitter itself, go to the emission tab, we'll see some of the basic parameters. We're spawning 1,000 per second, and we've got a speed of 20. So if I press play now, you can see our particles are constantly emitting in all frames, and they are continuing to move across our surface. Now that's quite inefficient because we're adding more and more particles to the scene, but we're not removing any, and you can see we actually get this really dense mess of trails. Now when they're flowing, they're going to look a lot prettier than this. However, we're still going to have the same problem of a huge amount of density getting a bit out of hand. And if we need to control that, one of the best ways is to give the particles themselves a finite life. So what I'm going to do is I'm going to go to the uncheck the full lifespan checkbox. I'm actually going to give them a lifespan of 6 seconds. So it's 180 frames. And I hit play now. And you'll see after 180 frames, which is here, the particles will start, some of them will start dying off, and this density will never increase. However, the problem there is that the trails that are following them will suddenly blink out of existence because there's no particle attached to the end of that trail anymore. And if I reduce the particle birth rate right down, you'll see as the particles move across the surface and their trails, they'll suddenly blink out of existence like so. So to mitigate that, to fix that, we're going to have our trails shrink at half the lifespan of the particle. And we're going to do that using a question and action setup. So we're going to have a question. We're going to add a question in the emitter here. And it's already set up exactly how we want it. And that is to test the particle age. If it's greater than 90, perform an action or even activate and deactivate modifiers. And we're going to be dealing with the latter. We want it to activate a modifier, and the modifier we want it to activate is the xpTrails modifier. And we can find that in the null here, or we could bring up the commander and start typing xpTrails mod. You can see it, that's this one here. And then we put that in the modifier stack there. And what it does is if we just press play now, you'll see it's shrinking the trail so quickly that there's no, it appears that there's no trail behind the particles. However, what we want is it to only trigger at exactly the halfway point in the particle's age. And so that's where this question comes in. Just drag our trails mod down into this field, activate, deactivate modifiers, modifiers to activate, and our trails mod. So there we go. We have our trails forming, and then at the halfway point, they actually shrink down, and you can see it catches up just before the particle dies because it's exactly half its lifespan. Okay, so now we've created an efficient, clean way of representing our flows. Let's actually start adding some flow fields and playing around with different topologies to see what happens with the flow. So first off, let's add a flow field object, and we can do that from our dynamics null inside our system object, and we can just go down here and add an xpFlowField. Now, of course, by default, all of the cell vectors are pointing in Z positive, so they're pushing towards the Z axis there. And if we increase the strength at which that happens, and we can turn off the vectors, the display in the viewport, and let them push our particles to the other side of our sphere. Now you see that they're still constrained by the follow surface, so they still stay on the sphere, but they all push to that one side. And we can, of course, we can rotate or transform this flow field to adapt that field. But we want to kind of play around a bit more with some more interesting effects. And if we go to the General tab, we can change the flow mode to random. And you'll see here, this is flowing across the surface. It doesn't care about the topology that it's flowing over. It's just using the random vectors inside each of the cells to generate the flow direction of the particles. So they're flowing, they're respecting the surface because of the FollowSurface modifier, but they're also utilizing their direction from the xpFlowField cells. So we're using geometry here, we're using this sphere, of course. So what if we change the flow mode to reference that? So if we use surface tangent and we make the surface object our source object, you can see we get these interesting flows. Now this, you could even say this is somewhat like a weather system where you get cyclones and you get different sort of areas of pressure, and some places they actually sort of neutralize each other where the vectors all sort of face each other. But we want to have a bit more control over this. So let's just experiment. If we just change, say, the type, the way that the topology is generated by the sphere primitive here, I'm going to change it to tetrahedron. And you can see here now that changes the tangents, of course. And I'll tell you what, to make the trail stand out a bit more, I'm going to go to the trail object itself, go to the basic tab, and I'm going to use a color. I'm going to turn the color on, and I'm going to make it a nice blue color, like so. Press OK. Now when I deselect it, you can see we have a bit more clarity when we see them up against the topology lines. Okay, so you can see that this one is creating sort of a vortex up here, sort of at the pole here, and then down here as well also. So that's kind of creating a system similar to something, a planet perhaps like Jupiter, which has these really obvious bands of flowing motion, the huge weather systems that Jupiter has, but it's not very controllable still. If I increase the number of segments, it's not going to have too much of an effect because the tangents will remain pretty similar because they're all relative to each other. Let's try another one. Let's try the icosahedron. Now this has the most even sized polygons, but even that is creating an interesting look, but you can see it's fairly evened out and we end up with these polar vortices, which we might want, but we want more control over where they form. So how are we going to control our weather system on the surface of our topology here without actually having to edit the topology of our planet? Well, we're going to actually use almost a donor surface for the flow field. So we're going to use a decoupled surface, and we're going to start with something extremely simple. So let's add a polygon object. I'm going to move it over here. And now I'm going to drag this into our other objects folder, and I'm actually going to put this inside a new connect object, and this is going to be our flow field driver. This is going to be driving the vectors inside our flow field. So I'm going to add a connect object, and we're going to call this one our flow. And then I'm going to put that polygon object inside there just so that we know that this is going to be the reference point. Go back up to our flow field, and I'm going to get rid of our surface connect object, and I'm going to replace it with our flow one. Okay, so now let's go to the display tab and show our vectors, and let's turn off our direction only so that we can see exactly what's going on here. Now currently the flow field is set to surface tangent, and I want to actually utilize the normal of this polygon. So I'm going to actually change that to surface normal, and you can see they're pointing upwards. And I don't want it to have any fall off. I want this to universally affect the whole flow field. So I'm going to turn the fall off. And there we go. And as I rotate this, you'll see I can now create an exact direction of where I want the particles to flow across the surface. And if I hit play, you'll see our particles move across this surface and they'll flow much like the default did all the way to the other side. Now where this gets really interesting is when I start to duplicate these surfaces. So we can think of these as sort of control surfaces. And I'm going to move one over here. I'm going to duplicate it, leaving it within the connect object. Then I'm going to rotate this side. Now can you see, because the cells that are closest to this polygon are all going to face that way, and the cells that are closest to this polygon are going to face downwards. And this is all based on the polygon normal of our geometry here. And to help us visualize that, let's actually use a couple of materials. So this is just useful for viewport analyzing surfaces. So I'm just going to create one material, and I'm going to call this one front. It's just a standard C4D material. And I'm going to change the color to let's use an orange color. Something like that. I'm going to duplicate that one, and I'm going to call this one back. This is the front face and the back face of a polygon. And make this one blue. Now I'm going to drop both of those materials onto our flow connect object. And I'm going to set the orange one to front, and this is the side of the polygon it's going to display on. And I'm going to do the same, but I'm going to do the back side for this one. So if I now move the camera around, you'll see our polygon has an orange and a blue side. Now the blue side is negative in the polygon normal direction, and the orange side is positive. So you can see our vectors will always be positive on the orange side and negative on the blue side. So that's our direction essentially. So if I delete the one polygon here, this is where it gets really interesting. We can actually duplicate these using another method. We're going to use a MoGraph cloner. So MoGraph cloner. And I'm going to put the polygon inside there. And because we're still within our connect object, it's still being referenced by the FlowField, and you see it actually getting updated. And now I'm going to put this in a radial array. So I'm going to change it from a linear mode to a radial. And let's make this larger so we can actually see the places where they are, the positioning of the polygons. And I'm going to shrink our polygon right down. Like, let's do sort of that size. And currently they're all facing outwards. So actually it's kind of behaving almost as a normal to push it away from the sphere. I want it to flow along the surface of the sphere. So what I'm going to do is I'm going to transform these polygons. And remember, all the cell vectors are doing is looking for the nearest polygon, and then it's taking the polygon normal, which in this case is on this particular polygon is this way. And then it's applying that vector inside the cell vector. And then in turn, it's going to apply that to the particle. So what we need to do is we need to transform those polygons and change their direction, their angle orientation to affect the flow field. So I'm going to go to the transform tab of our cloner. And if you see, as I rotate these, you'll see our vectors transform as well. And then if I do on bank, and this is the interesting one, if I do 90 degrees on the bank, you'll see that we actually create a circular flow field. Now let's hide our flow lines, our flow vectors. There we go, our cell vectors. And I'm going to hit play, and now we're going to see we've created a system that can rotate, that can have our particles flow in a rotational motion across the surface. But the difference between using the original topology of the sphere itself is that I can actually transform this. So I can move this, I could rotate this around, and this essentially becomes our equator of our planet. And if I rotate up here, and so now we've got this flowing of the particles across the equator here. We can also do something very interesting, and we could of course use a spline to create the same effect. We could use a circle spline, but the advantage of using the geometry from this cloner here and these individual polygons is that we can really customize how this shapes our flow. So I'm going to increase the number of them like so. Then I'm going to actually introduce an effector. So I'm going to add a random effector. I'm going to put that above the connect object. I don't need it to be inside. And you can see it's actually moved them all away by default. If we go to the parameter tab of our random effector, you can see it's moved them in position. I don't want to do that. I just want to play around with the rotation. So I'm going to enable rotation, and then because we're going to change them on the pitch, if I do that, you'll see that our flow is no longer exactly perfectly straight along this center line, and we actually get some randomization. Now, the effect isn't particularly pronounced at the moment, and that is because if we go to our flow field and we show our vectors, there aren't that many vectors. It's not a very dense flow field. And if we need to make sharper motions, or we need the direction of the particles to change more frequently, we're going to need more cell vectors. So if I go into the General tab, we're going to reduce the cell size all the way down to 10. And you'll see immediately the particles start to respond quicker to the change in direction of our polygons here. So this is really cool. And if I rotate our cloner here to exactly 90 degrees, like so, and you can see the more I set the random up high like so, we can actually even invert the direction of the field, and we'll get these very interesting flows where you'll see we'll get poles and at each of the top and bottom, but we also get these kind of intersecting flows here as well. So we get these vertical flows where the polygons, the nearest cell vectors are actually colliding with each other. They're pointing at each other, and we get this kind of neutral position where we get these vertical lines. So now that we've set the basics up here, we can actually even duplicate our cloner. So let's grab our cloner here. Let's move that up in Y, and let's actually deactivate the random on this particular one. So let's go to the Effects tab and just turn off the random. And now let's play and see what happens. Now you can see that the nearest polygons to these cell vectors up in this hemisphere are all pointing in the same direction, so we get a consistent flow in that direction. So what happens if I do the same, but I create one down below as well, like so, and then I can reverse the flow by inverting the direction of these polygons. So I'm going to go to Transform tab, and then I'm going to hit negative on the bank transform there. And you can see immediately, and we can hide the flow geometry, that we're starting to create a very interesting looking planetary weather system where it's flowing across the surface, and we have control over where and how it moves and flows. Now we should rename these just so that we're consistent, and we'll call this one middle, top and bottom, like so. And if I can deactivate individual ones of these to get different effects. So if I reveal them again, and I actually just deactivate the middle one here, I just disable both the cloner and the polygon, you'll see that our flows actually just perfectly, because they're exactly in line, will actually just go opposing north to south poles. If I slightly randomize these, so if I select both of our cloners, go to Effects, and enable our random again, our random effector, you'll see that we can actually create a whole sort of randomization to our system here. And you'll see that we're getting sort of somewhat sharp turns. So you'll see that suddenly they'll move here, and then suddenly they'll move quite sharply in another direction. And that's due to the number of clones we have here. You'll see that they're only changing every so often. So if we want a smoother transition, we simply create more of these. And in fact, because we're using the same random effector, we're getting the same randomization on the north and south pole. So what we could do is we could just offset that like so, and now we'll get way more sort of intersecting flows, and you get these sort of nice sort of spiraling there, a bit like a cyclone. The other thing that's causing the sort of quite angular changes in direction is that we're forcing them quite heavily using the high strength parameter. So the strength parameter is a rate of change parameter. So it's how quickly the vector, the direction on the particle, will be given to the particle. So currently it's immediately applied to the particle, whereas if I drop it down to 50%, it's a much more gentle flow, like so. So that's something to bear in mind. And now we can, say we disable the lower one. In fact, if we turn the randomization off both of those, so let's turn off our random effector, and let's turn our middle one back on, and let's turn the bottom one off completely, like so. And of course, we're going to increase the number of clones on our middle one as well to match, or to at least be high frequency like the other one. And there we go. So now we get a north hemisphere of them just flowing around from west to east. And then down here, we have a much more complicated flow because of the randomization. So what I want to have the flows kind of intersecting, and we have these bands of difference. So the bands are the top, middle, and bottom, like so. But then I also want to introduce some sort of gentle randomization. So we can have maybe on the poles a bit more randomization, a bit more turbulence, if you like, in the actual weather flow. So what we can do is we can introduce a new flow field. Let's hide our main flows there. In fact, let's show our flows, and let's have them all on an axis like so. Let's rotate them. There we go. And that looks a bit more interesting. Like so. And you can see these areas here are where the vectors actually end up spiraling in because they're all facing in a loop and the particle can never escape. So that's really interesting. And what we're going to do is we're going to break up the top area here with a new flow field. So I'm going to add a random. So let's rename this top one here. We'll call this one surface flow because it's the main flow on the surface. And then we're going to add another one. So add another flow field, and we'll put that after the first one, and we'll just rename this one random. And then of course we're going to change it to the random flow mode. Now the strength of this, we can set this to quite high. Well, let's go to a 50% again, like so. And you can see that's now taking over the particles almost entirely. So we're going to have to choose the area at which this is going to affect our particles. And I'm going to drop the cell size down. Now the cell size affects how big the swirls are. So if we want to make this look like a large planet, we'll go to a very small cell size, turn the vectors off, and you can see we get these much more fine and small areas of swirls. So if I want to limit this to a specific area on our sphere, the easiest way is to use falloffs. And so if I go to the falloff tab, and we're just going to use a simple spherical field falloff, and I'm going to place this up on where the pole was forming. So if I press play, and you can see now I'm creating this randomization on the pole here, but everywhere else is not being affected. Okay, so I think we can up the particle count now just to get a really good look at how this is looking. So let's go for a much higher birth rate of 1,000. It's going to show us the flows a bit clearer as well. So that's looking really cool. And with our fall off here, we can place this anywhere and we'll actually get zones of sort of turbulence, zones of more vorticing on our huge planet. This is a gas giant, obviously, here. Okay, and lastly, to add to this effect, I think I'm going to add a secondary effect of sort of coronas coming off the planet, just for sort of visual effects. This is perhaps something that would be useful in an FUI scenario, sort of a motion graphic scenario. And so what I'm going to do is I'm going to add another emitter, another set of emitters and trail objects, and I'm going to have it not follow the surface. So we're going to do that using groups, but we are going to utilize the surface shape. So the spherical, currently it's a spherical surface shape. We're going to use that to push particles away from the surface, and then we're going to have them kind of randomly sort of flow using another random flow field. So I'm going to call this surface random, like so. And then I'm going to add a new emitter. So I'm just going to add a new emitter here. I'm going to change its color. I'm going to change it to sort of a warmer color. I quite like using the Kelvin slider. It gets quite a natural orange there. And then I'm going to make the particles the same color just so I can identify it. And we're going to call these ones our free particles. These ones are free from the surface. And then I can actually emit them in any way I like. Because it's a flow field, the emitter can be pretty much free to move wherever it wants, and it'll still be affected by the field as long as it's within the actual flow field object itself. So I'm just going to create a circle. I'm just going to move it up to this side for now, like so, and then we're going to edit that later on. If I press play now, you're seeing it's getting affected by all of the the other objects in here, and you can see our particles are actually flowing around and orbiting our planet. So this is really cool. This is a way that we can create sort of satellites and asteroids, and then even some of them get sucked in and end up actually stuck on the planet there. So let's add a trail object for our new free particles. Let's call that the one, the free ones. And this one is the surface. And let's give that free ones a color. Like so. Now I want these trails to dissipate exactly in the same manner as the surface ones. So I'm just going to set it up in exactly the same way. I'm going to make sure there's no color and thickness data. Go to the general tab. And then if I hit play, you'll see them forming and flowing around. And in fact, some of them are even getting caught onto the planet itself by the follow surface. And then if I grab our emitter that we just created, and we have the same question apply to it, which is this particle age question. So go to questions, particle age, and then this will now diminish that trail object. So it'll start to sort of keep them in check a little bit. And there we go. We're starting to get this rather cool orbiting set of particles. And remember, this is based on all the flow fields we already have in here. And we're going to introduce another one in a second as well. But here we are. We're going to place this this particle emitter around the center of our planet, just to kind of give it an initial state. So I'm going to make it a ring emission. I'm going to make it quite large. And let's zero it out. And then let's place it, say, around the center here. Press play, and you can see we get an absolutely wild effect because we are now much nearer the random cloner, so the middle cloner, than we were the other ones. So I want it to be a bit of a mix between them. So I'm actually going to put that a bit off center. And there we go. We start to get a really interesting looking flow of particles that are free from the surface, but they're still utilizing all of the flow fields that we have created for the surface. So let's drop the number of particles right down. And I'm going to drop the speed right down as well. Currently, they're very, very fast. And there we go. So we don't have to constrain them to our planet's surface. But as some of them do get close, they will get grabbed in by our FollowSurface modifier. But if we don't want them to be grabbed by the FollowSurface at all, and we want to let them just move away from the planet, or however they're going to work, we can actually have them ignore the FollowSurface using a group object. So if I go to the original surface object, and I'm going to create and add group, and I'm going to do the same for our free emitter, create and add group. We'll call this one free, and this one, of course, surface. And then all we need to do is we need to go to the modifier, the FlowField modifier, groups affected, and then only affect the surface group, so the group surface there. And now these particles, they won't get caught up by this surface, but they can still get caught up by the flow field. So you can see here now they stay off the surface somewhat. Okay, so now we've got our basic system set up. We can experiment using different pieces of geometry as our planetary surface. And we're going to do, first things, we're going to swap it out. We're going to swap it out with a torus. So let's go back to frame 0, and let's collapse our system, and we're going to call this our planetary weather system. And we can give it a color if you like, just to identify it from any new systems. And let's go back into our surface here. This is our particular surface that is the planet right now. So I'm going to actually remove that. Let's grab our torus that we had earlier. And this is just as an example piece of geometry. And let's give it some more subdivisions. If I press NB for wireframe, you can see we could do it some more. Make it nice and smooth, like so. Let's go back and let's hit play again. And now immediately our system has been applied to a totally different piece of geometry, but it's respecting all of the settings that we've applied on the flow fields, on the follow surface, and so on. So our extra emitter, our orbiting free particles, obviously don't suit particularly well this particular size torus. So we could reduce the torus size right down, and then we could even have them follow around like so. And you get really interesting effects with different pieces of geometry, but we are maintaining and we are keeping the same overall flow directions because we've decoupled that flow direction from the source geometry. We're getting quite a cool one here where they're orbiting around that torus there. Okay, so let's try something completely different. Let's try a cube. And let's put that in our surface connect. And let's put this one here. And then I think we should have our free particles come out of a rectangle instead this time. So let's do rectangle. And let's orient it pretty much the same way, like so. Go back, hit play, and it works even on our cube object. Awesome. I've noticed that the particles are emitting on the whole of that rectangle and not just on the edges. So I'm just going to click on that emitter here and say edges only, which means it'll only emit on the rectangle's edges. And that would give you more similar effect to the ones we had before with the other shapes. And of course, we can rotate, edit, change this particular set of flows anytime we want. And we can change the poles where the actual flows occur. And we could even remove the smooth flows and just have an entirely random flow over the surface, depending on what kind of vorticing, what kind of cyclones and effects you want to create. So there we have it. That's our rig completed for a simple planetary weather system utilizing the xpFlowField.